So this is a math video and it's about logarithms. I just have to invite my friends to a Zoom call. One sec. Alright. Oh, there he is! Alright, so now... Are you pissed? Logarithm, logo, rhythm, logos, rhythm, logic and music. A logarithm is one of the big three Bosch power tools. It's just a simple math function used to solve exponential equations, do some cool stuff to exponential graphs. Good stuff. But you're not here because you want to know when to use it or any of the fancy stuff. You're here because you're right like 10 minutes before an exam and you want to smash and bash it, cram it into your brain. So let's go. We'll start by taking the logarithm of 1000. I know you have no idea what you're supposed to do, but just count the zeros. 1, 2, 3. Alright, so the logarithm would be 3. Now, what about 10,000? There's 4 zeros, so the logarithm of 10,000 would be 4. What about something a little bit more difficult? What about the logarithm of 10 to the 15? Well, 10 to the 15 is just 10 times 10 times 10, 15 times. Which means there's 15 zeros, and the logarithm would also be 15. And if, let's say it's negative 15, so logarithm of 10 to the negative 15, well, it's 0 point and then 15 zeros, so the logarithm is literally, once again, negative 15. It's whatever is in the exponent.
Wait, hold on. It seems like we figured out an equation we could solve to get the logarithm of a number. Crazy, right? So basically, log of x is the same thing as asking 10 to the power of what equals x. So yeah, we're essentially asking ourselves 10 to the power of what is equal to the number we put in the logarithm.
Indeed.
Ha, that easy. Which means you don't have to count zeros, you can put in 35 into the logarithm and it will be a number too.
Alright.
This might be a little off the curriculum for now, but what if I want to change something in this equation a teeny tiny bit?
Sure, go ahead. Which one?
The base.
You inebriated donkey. You good for nothing potato.
If you want to change the base, all you have to do is write a number in the bottom right edge of the logarithm, and you've done it.
Well, Isaac, you gonna explain the exceptions?
Well, thank you for
No,
reminding
okay,
me.
Gabriel, why did you remind him?
So,
Why did
if you don't
remind
write
him?
anything in the bottom right of the edge, it either means 10, 2, or E. If you're talking to the mathematician, the base is probably 10. If you're talking with a computer scientist, the base is probably 2. And if you're talking to a dead person named Leonard, the base is E.
Leonard Euler, yeah. So what is this E, you might ask? It's just a number 2.718 or something like that. All you have to know, if you're going to write log base E, instead you can just write ln. Much simpler. The n stands for natural, so it's called the natural logarithm. And I think it's about time we roll some ads. So that would... Can we get some ads up here?
Chicken.
We'd like to take a moment to announce all our food keeps blowing.
Now there are some rules you need to use. Rules doesn't mean they're restricting you in any way. Rather, they're rules that are helping you. Yes, that's exactly what I said, use and not follow. Starting from the simplest, we're going to go through all 8 rules. Rule 34, 1. We can just check this with our calculator. But for good measure, b raised to what equals to 1? Go ahead and check your power rules. Bosch power tool. That's right, b to the power of 0 will always be 1, no matter what b is. So this rule is true. Rule 2. We could also just do this with our calculator. But b raised to what equals to b? That's right, 1. Rule 3. This expression is literally just asking b raised to what is equal to b to the power of k. Of course the answer is going to be k. Rule 4. This one essentially lets us move back the k in the exponent to instead multiply k by the logarithm. Starting with rule 2, we can find that raising b to the power of k essentially multiplies 1 by k. Wow, crazy! We just figured out rule 3 again. We could also see that because log b of b equals 1, you could rewrite the right side to be k multiplied by log b of b. Now you can also see that changing the value used in a logarithm from being same as the base to being some other value m doesn't make it invalid. Rule 5. If you take log base 10 out of 100,000, it will be 5 because there are 5 zeros. So log base 10 of 1000 plus log base 10 of 100 should be the same thing, since there are 3 zeros in 1000 and 2 zeros in 100. 3 plus 2 is 5. Rule 6. This one is the exact same, except with opposite operations. Instead of multiplication, we use division. Instead of addition, we use subtraction. You can try putting some numbers into the function on your own. You'll figure it out. Rule 7. You can prove this by using rule number 4 and some trickery. Let's say m equals b to the x, and then consider the equation log of m equals log of b to the x. See that changing the base doesn't make the equation unequal to itself. So we'll just set it to k. We can now use rule 4 on the right side logarithm, moving the exponent to the front. Remember, if you ever forget what a rule means, rewatch that part of the video. Now we can divide both sides by the right side logarithm and get log base k of m divided by log base k of b equals x. X? But what is x? Did we mess up? No, go back to the assumption we made in the beginning. M equals b to the x. If we use logarithm on both sides, let's just say base b, you'll notice why. It looks like the thing we just had. The key difference is that base. We use rule 4 just like before. Do you see the rule 3? Log b of b becomes 1. Multiplying by 1 does less than that one pink-haired character in Naruto. So log base b of m equals x.
So that was what the base was for.
So we replaced the x in the previous equation with the stuff we got now. And we get log base k of m divided by log base k of b equals log base b of m. Rule 8. The final one might sound like something an insane Frenchman would write down during the war of 1465 degrees Fahrenheit kilometers. But turns out it's just a reversal of rule 3. You could literally just use rule 3 and 4 to prove it like this.
Oh yeah. Playing some Pokemon today, man. Pokemon. Great game. Okay, let's see. Red is using... Okay, I've never seen someone use that. Good thing I have Isaac on my side, so that's good. Alright, what is the first attack? Well, thank God that I took that math course. Okay, that was good. So, at least I know logarithms. Let's see. First step, I'm gonna look on the left side. Logging 1, yes, logging 1 is basically doing nothing. So, log of 1, no matter the base, becomes 0. Alright, second step, dividing by 0, does nothing. Alright, the whole left side is 0, don't care about that. And then 0 minus, and the whole right side will start from the center of it all, 5 to the power of log 5, 32. Okay, oh, I remember what to do now. Okay, so when you're raising 5 to the power of logarithm base 5, it's the same base on both, so it just cancels and you just got 32 if I'm right on that. Alright, Next step, log of 2 of 32 squared. Okay, so we can use one of the rules to just get down the 2. That's great. And 32, that's just 2 to the 5, I think. Yeah, so log base 2 of 2 to the 5, because there's the 5 in the exponent, that logarithm should be 5. Alright, let's see. Then next, 5 times 2. Okay, it's 10, obviously, of course. Super easy. Alright, but then we have 10 squared. Okay, so 10 squared is 100. So there's 2 zeros, and log base 10 of 100, because there's 2 zeros, that would be 2. And the log base 2 of 2, that's just rule 1. That's, I think it's rule 1. Not Rocket League, not Rocket League math. Alright, so it turns out it's 0 minus 1, which should be minus 1. Let's see if that works. Please work, please work, please work. And that's you kill the boss. Great stuff. Thank you for watching this math video about logarithms. Links in the description below to relevant sources or relevant material for you studying. In general, good luck with all math coming. And the next episode, coming out 2035, maybe, possibly, it's going to be about derivatives. Have fun. Good night. Good luck.